Okay, so let's start with the first one. We need to get the surd alone, one side. So that 4 has to go over and becomes minus 4. Then you square both sides. So this side, the surd disappears. And on the right hand side, you must just remember that when you square a binomial, it becomes a trinomial. There must be 3 terms there. Alright, then you just shuffle it, get everything on one side, factorize, you get your 2 brackets, and your 2 answers will be 7 and negative 2. When you test it, you all know how to test it, you will see that only 7 works. So you cancel the answer, that's 2. Any questions about this first one?
When we get 2 answers for will it always be that one of them won't work?
Technically, no, but for an exam, yes. Because if both of them work, no one would know if you tested them. Okay, so for the sake of seeing whether you're testing them, one of them won't work. Okay. Right, G. So there, yesterday someone in the Afrikaans class asked if they can square this side and then square that side. Right, you can do that, but you must remember on this side there are 2 terms now. So what happens when you square a binomial? It becomes a trinomial. So you're going to have a middle term that's still going to have a surd in it. So that won't really help you. So the first step you have to take is to get one surd on the one side, one on the other side. Remember, when we have an equation, we work towards getting one thing on one side, the other thing on the other side. Always. Square both sides, and then it's a simple solve for x sum. And you get x to be 1. Everyone fine with that? Okay. H, once again, is an exam-like question. You get the surd alone on one side. Looks like that. Then you square both sides. This side, the square root disappears. This side, it becomes x squared plus 2x plus 1. Get everything on the same side. Factorize. You get your 2 answers, negative 4 and 1. Negative 4 doesn't work when you test it. Negative 4 works, 1 doesn't work, sorry. Any questions? Okay, at I, what I wanted you to notice there is that it's one term. It's important whenever you get a question that you notice whether it's 1 or 2 terms. So because it's one term, you can literally square this side and raise the power to each square root. And then just square the other side. So at this side, you would get rid of the surd, you would get rid of that surd. Just remember they are still multiplying, and on this side you would have 9 times 2. When you multiply that out, you get x squared plus 3x minus 10 equal to 18. Get everything on the same side. Then factorize, you get negative 7 and 4, and the one that doesn't work is negative 7.
I'm just trying to see this together.
It's fine. Okay, I just want to say what Courtney is saying here. She put this under one surd, basically. Okay? So you can do that when it's the same type of root. So if both of them are square roots, you can do that. Or if both of them are cube roots, you can do it. But if it's different surds, you cannot do it. Okay. So that is everything that we have in the first chapter. That's what tomorrow's test will be on. So what the Afrikaans class and I did was we just took some questions out of old question papers. Obviously many of them I took the level 4 question, the one that looks a bit funny, just to show you how it all works out in the same way. I think the kids in the Afrikaans class got quite a rude awakening when we were doing this. I'm going to say this again. When we did the exponents, do you remember the exponential expressions? That was exercise 2. That was the first grade 11 exercise that we did. When we were done with it, all of you could do it. Every one of you. There were no problems. It was not difficult. But I've told you, when we're done with something, don't stop doing it. You don't need to buy 10 different textbooks or extra help books or whatever. The steps that you're going to have to take stays the same. So, I asked in that class as well. I'm not talking about in preparation for the test of tomorrow. But how many of you have been keeping up with the work that we are done with? You don't have to put up your hands whether you have or whether you haven't. I know what it's been like the last 3 weeks. It's been busy. I get it. But you are going to have to make time to keep doing what we've already done. So tomorrow we're finishing with exponents. Then we're starting equations, algebraic equations. We won't be doing any of this there. None of it. So you're only going to do this stuff again when we write exams in March. Okay? So please don't stop doing it. They couldn't do the sums in activity 2 when we were doing them here because they forgot it. We don't have time to say, oh, we'll have an extra class and redo everything. We have to redo everything thoroughly. We need to do it next year when we redo everything. If you're not going to keep yourself going with the work. Okay. All right. So the first one, I'm just going to write the sum on this page first. Wait, let me write it here so that you can see what it looks like nicely. So it's the square root of x plus the square root of 2x minus 1 times the square root of x minus the square root of x 2x minus 1. Okay, I want to help you to get started with this one. Firstly, I want to know, can we square this to get the square roots away? Can we put a bracket and square and then just get rid of those square roots? No. You can do that when it is an equation. That's what I said yesterday when I told you all to look me in the eye. Remember? Okay. I said that yesterday and today you're saying yes, we can square the square root away. This is an expression. You can't put anything into it. You can't take anything out of it. Right. What we can do, if you want to, is because these two are multiplied, is we can put it under 1/3. Okay? So we just take that part away and we complete it. But then we have to put brackets there. If that second third is bothering you, you can also write it like this. Okay, so what I did is put it under one big third, but then I changed that big third to a power of a half. I haven't put anything in there. I haven't taken anything away. All I've done is I've changed the format. I've changed what I see there to look different. But I didn't change the sum. Now I hope that maybe if you didn't see it there, when you see it in this format, the way I've written it here, you notice something about what's in this bracket and what's in that bracket. What's in this bracket and what's in that bracket. Do you notice something about it? Let me read it to you. It says x plus the square root of 2x minus 1 and x minus the square root of 2x minus 1. It's the difference of two squares that has been multiplied out. Which means I can write these two brackets differently. I can make them smaller by saying it's this one's square root minus this one's square root. So what is x's square root? Ach, not square root. This one's square minus this one square. What is x's square? X squared. What is the square root of 2x minus 1 squared going to be? The root and the square will cancel out. Okay? So I will basically have x squared minus 2x minus 1. But there are two terms underneath that thing. If I have x minus 2x minus 1, if I write that down, I'm only subtracting the 2x. Can you see that? I mustn't just subtract this one, I must subtract the whole second part. And therefore, this will have to be in brackets. So what I did from here to here is I wrote that big square root as a half. Then I noticed that those two is actually the same as x minus y, x plus y, which is the difference of two squares multiplied out. So I noticed that, so I write it back in the difference of two squares format, which will be this one squared minus the second one squared. The square and the square root got rid of each other. But it's two terms that must subtract, so therefore it must be in brackets. So when I multiply that negative into the bracket, it becomes x squared minus 2x plus 1. Do you see that I have not done anything that we haven't done this term? I haven't been there teaching you to do some sort of mathematics and now I'm showing you something different. It's the things that we have learned, implemented in a different way. The package is covered in a different paper than we used to. Who has a plan for me? What can I do with x squared minus 2x plus 1? What can I do? Can I take that half and multiply it in? No. You can only raise a power when it's one term inside of the bracket. There are three terms inside of the bracket. What type of three term do you see here? Quadratic. What do we do with a quadratic trinomial? What do we do with quadratic trinomial? We've been doing it this whole week. We factorize it to bracket. Eh? Okay. So I'm going to say in the one bracket x and the other one x, then factors of 1 that will give me 2 when I add them. 1 plus 1. Okay? But I want to get negative 2, not positive 2. So it's going to be minus 1 and minus 1. Okay, I need you guys to help me. What can I do next? Is there a different way that I can write x minus 1 times x minus 1? If I have 5 times 5, how can I write it differently? 5 squared, okay? So this is x minus 1 times x minus 1. You see I can write it x minus 1 squared. Now let's just anticipate what's going to happen. If I have a bracket with a square to the power of a half, do you see what's going to happen there? So I have a bracket with a square to the power of a half. Not to be mistaken that when I multiply these, I'm taking it to each term. That's not what I'm doing. This is considered one term because it's in one bracket to the power of 2. And therefore that 2 can multiply with the half for it to become x minus 1. Now remember, when you go home this afternoon and you prepare for the test, you can close these sums where we've done it. Just write down the question and see if you are able to do it by yourself. You have the answers, you have the way to do it. If you work out old question papers, this work is question 1 and 2 of paper 1. Okay. You guys know that app, grade 11 mathematics? You have it? Okay, let me just show the ones that don't have it. It looks like an eyebrow. Then you go on it now. I know you can't see clearly there, but it has practice problems, examples, activities, March tests, June exams, September test, exemplar, November exams, download papers, everything in here. So if, for example, you go to November papers, and this is now November exam of 2022, and you choose question 1 to 5. It has the questions there, and right underneath it, it has the answers as well. Okay, so it's nice to practice from there because you can immediately go to the answer. You don't have to download the question paper and then download a memo and what. It's all there. You close it, you try the sum. Can you see question 2 there? Not really. Exponents and surds. Exponents and surds. And then question 1 is normally the equations. So there you might find the quadratic equations or the surd equations. Okay. The next one. Two to the power of x square root x equal to 2 to the power of 27. Can you see that these bases are already the same? Which means I can throw them away right from the beginning if I want to. Okay. I'm sure the other thing that bothers you, or the thing that bothers you here, is the square root x. Can I change it? What will it become? X to the power of half. So you can either do that first, or you can, in the same step, do it and throw the bases away. Because the bases are the same. Do you see that they are being multiplied and they've got the same basis? So what do I do with the exponents? We add them. And 1 plus a half is 1 and a half. And 1 and a half is 3 over 2. Then it looks like that. X to the power of 3 over 2 equal to 27. What can I do to get 3 over 2 to be 1? Times of 2 over 3. And then I do the same thing there. So this one becomes x. And then what you can do with that one is you can either make it 3 to the power of 3, that multiplies with that exponent, so the 3's will cancel out, or you can go to the surd form, because it will be the cube root of 27 squared. And that gives me 9 either way. If you're done with that, you can start with the next one. Try it so long. There are 2 terms on this side and no terms on that side. Can you all see that? That's a problem. Because we only want this equal to 0 if I've got a quadratic equation. This is not quadratic. If it's quadratic, the one exponent will be double the other exponent. Not happening there. Then you would have a negative here and a negative here, then you would just have to divide with a negative. But it would be fine. When you look at this, you see normal, normal, exponential. Normal calculates with normal. There. I cannot hear a word that you say. What? That sign? This sign changes. This never changes. This one changes. Sign in front of it. Okay. Remember, this one is a negative 16x to that power. Okay, so you're not listening anymore. You're listening now. Okay. That's not something that I take over. You take over the whole term. Therefore, the sign in front of the term changes. Okay. Did you also think about dividing both sides of 16? And then I've got 1 over 8. I don't like the way that 1 over 8 looks. Can I make it something else? What is 1 over 8? Why are you going to decimal? 2 to the power of negative 3. So I've got it looking like that. 2 to the power of negative 3 and x to the power of negative 3 over 2. If I want this exponent to be 1, I'm going to multiply with negative 2 over 3. And this side the same. Remember, I can put things in on both sides because they are both sides. There's an equal to sign. If it's an expression, you can't put things in. You can just manipulate the form of the expression to look different. When I multiply here, it just becomes x, and here the 3 and the 3 cancel out. The negative times the negative becomes positive, so it's 2 to the power of 2, and that gives me 4. Yes? But if you kept it 1 over 8, you would have to, and you have that exponent there, you'd have to write the third form. Okay, because it's not likely that if I ask you what is 1 over 8 to the power of negative 2 over 3, that you would be able to have that answer without doing a calculation and without using your calculator. Okay. Right, next one. I hope you get a bit of a fright when you look at this one. So they are asking you to simplify as far as possible this fraction. Write it down and then we're doing it together. Okay, the first thing I want you to see and not be scared of is when they say, they give a note like where for P not equal to Q. That does not influence our calculation. The only reason they put it there is because if P and Q is equal to each other, that would result in a denominator of 0. And that would be undefined. Okay, so it doesn't influence anything we're doing, just keeps this equation from disappearing. Okay. Now looking at that, a little bit of a light in this tunnel is if you look at the numerator, I hope you notice it's one term. That's good for us, né? Because if it's two terms, there's a lot of things we can't do, but that's just one term. And when I look at the bottom, it's also one term because it's in a bracket. The other thing that's nice about this is that there's a lot of repeating happening. There's a P and a Q, there's a P and a Q, there's a P and a Q. That's good. Something that bothers me is that this is exponential, but that's a surd. I cannot go and put in a square there because it's an expression. But what I can do is I can change from surd format to exponential format. And I think that would be a place to start. And then it would look like that. And I think it already looks easier. You can, but just remember, if you don't have the same surds, for example, this would be a square root, this would be a square root, but this would be a square root to the power of 5. It's a square root, but to the power, then your bracket will be to the power of 5. There is literally only one thing that you can do now. Only one thing that you can do. If you look at this one, there's nothing in that bracket that you can do. Look at this one, nothing in the bracket that you can do. But this one has got something in the bracket. What is it? What are these three things in this bracket? Difference of two squares. Is there a different way that I can write difference of two squares? Yes. It's a bracket that has each one of them in, one of a plus, one of a minus. And then, oh, don't look, don't look. It will look like that. That half was actually on the outside with a big bracket. But there are two brackets in there and it's one term because they're multiplying. That's why you can raise the power to each and every one of the brackets. Okay, let's go through the steps of what we've done so far. Now you tell me if any of this is something you didn't know. The first step we took was changing the surd to exponential. The second thing we did was to see that this is the difference of two squares and write it as two separate brackets. Okay? The reason we did that is because these brackets are in their simplest form and that bracket isn't. So we are trying to get everything to look the same. So when they look the same, then we can do something with it. And do you notice that this p minus q to the power of a half can cancel out with this p minus q to the power of a half? And these two, with the exponents, they have the same base, p plus q in brackets. And when they have the same base and they multiply, I can add the exponents, which makes it 6 over 2. And that gives me p plus q to the power of 3. Okay, now, very often in an exam or a test, you guys might have gone this far. Now you don't know, must you multiply the 3 brackets out again? The question was to simplify it. Simplify it. Okay? This is the simplest form. In grade 9, where you multiply this out, I can't remember what the English word is, but the Afrikaans word instruction for that would be brei uit, expand. Expand the following. Do you remember instruction like that? What did this instruction say? Simplify. Don't expand again. Okay, and that's it. That's the answer. Okay, let's see what you can do with that. Two terms at the top, very good. It's a problem, ne? What do we want to do when we have two terms? We want to make it one. What are the methods that we can use to make it one? Take out something in common or any other form of factorization. I'm sure you can see when you look at this that the m to the power of 3 and the m to the power of 3 is exactly the same, which means I can take it out in common. Something else that you can remember that you can do is to give each exponent its own base, just so that you don't lose it somewhere. Also here can be a 3. Do I take something out here as well? No, it's one term. So it doesn't matter where the 3 to the power of m stands, you can cancel it once you've taken it out at the top. Okay. Do you agree I'm going to take out 3 to the power of m? Okay. So it's 3 to the power of m, and then what remains is 3 to the power of 4 minus 6 times 3 to the power of 1 over 7 times 3 to the power of m times 3 to the power of 2. Now I can cancel, ne? 3 to the power of m with 3 to the power of m. Here I've got 81. Don't ever work next to each other like I'm doing now. I'm afraid I won't have enough space. 81 minus 18 over 7 times 9. That gives me 63 over 63, and that's equal to 1. Always when we do these exponential sums, I think that we really realize what the instruction simplify means. Can you agree with that? You have this big sum and you simplified, you made it easier. You got rid of all of the extra stuff to get it to be 1. And I just want to say again, remember you haven't found the value of n. n is not 1. When I simplify this, it means no matter what the value of n is, the answer will always be 1. Okay? That's an expression. Ready for the next one? This one. You can skip that one now. Prove that. Is this an expression or equation? Mixed answer. Some say expression, some say equation. Those of you that are saying equation, you are just looking and seeing that there is an equal to something. What do we do when we have an equation? We find the value of x. What are you supposed to do here? You are supposed to show that this expression, once simplified, will be negative 2. So what is this? An expression. Which means after seeing equal to negative 2, you are done with the right hand side. It doesn't walk with you. There are 2 ways to do this sum. You are going to do it yourself, but I'm going to tell you what the 2 ways are. The first way is going back to grade 8 and doing or following those steps that you wrote in this same class for adding and subtracting fractions. The steps I had you write down: number 1, make all mixed fractions improper, not necessary. Step 2, find the LCM denominator. Okay? That you're going to do with those 2. Do you see they can't be, this one won't be able to go into that one, or that one won't be able to go into that one. Now, do you remember if you had something like 3 and 7 as denominators, what did you do with 3 and 7? You just multiplied them. Same thing you're going to do here. You just multiply those 2 terms with that one. That's the LCM denominator. The next step was, what you do at the bottom, you do at the top. Okay? So what did you multiply this denominator with? Root 8. You do it at the top. What did you multiply this denominator with? 1 plus square root 2. You do it at the top. Okay? Then we said when your denominators are the same, only add or subtract the numerators. So after you multiply those things there, you simplify, you add and subtract them. And then it's just simplification to get to the answer. That was the reason why I made you write down those steps in grade 8. Because we're using it here. Exactly as you wrote it. Because the secret to mathematics is that everything stays the same. Okay. That's method 1. Method 2. You are also going to use method 1 as with that one. But it might make it a bit simpler with less gokkas here. Do you see this is the ugly denominator? And this is the ugly denominator. These are irrational denominators. And do you remember a while back we looked at rationalizing the denominators. What would we have done with this one? Times with 1 minus root 2 at the bottom and at the top. When I multiply with it at the bottom and at the top, I'm multiplying with 1, so it doesn't change. What would I multiply this one with? Root 8 at the bottom and at the top. And then after you've rationalized the denominators, you're going to follow your fraction steps again. Okay, so you guys start with that. Remember, they've given you the answer, so you must get to -2. If you're done with it before and this is the last sum that we're going to do together, you can start with it so long. Okay, let me show you without rationalizing the denominator. I got the common denominator there. I multiply that one with root 8. I multiply that one with 1 plus root 2. Then it's just simplification. So it's 2 times root 8 is 2 root 8. Negative 8 times 1 is negative 8. Negative 8 times root 2 is negative 8 root 2. Everyone fine with that? Then I just multiplied the denominator as well. Root 8 times 1 is root 8. And root 8 times root 2 would be root 16. So it's nothing funny. I just did the maths. Multiplying in distributive law. Now I'm going to get all of these surds in the simplest form. Because this one's got the 8, this one's got the 2, this one's got the 8, that one's got the 16. I can't take out something in common or do anything with it when they're all looking different. So 8 I change to 4 times 2, which is 2 root 2. But that multiplies with the 2, so it becomes 4 root 2. Minus 8 root 2. So I see similar terms there. At the bottom, I've got the root 8, which becomes 2 root 2, and the root of 16 is 4. Then I simplify the top. I say 4 minus 8, it's minus 4 root 2 minus 8. And at the bottom, it's just 2 root 2 plus 4. 2 terms, so I can't cancel anything. So what I'm trying to do is get something in common. Now this one I see both have a negative 4 in them. So I took out a negative 4, then it's root 2 plus 2. And at the bottom I took out the 2 in common, then I've got root 2 plus 2. So those brackets cancel out, and my answer will be negative 2. I just quickly want to show you, can I take picture and put it on the group as well? Okay, but I want to show you the rationalization. It's much easier. Once you've rationalized, it will be 2 times 1 minus root 2 over negative 1 plus the root of 8. Okay? Then I just take that negative up because it's over 1, and then it looks like that. Negative 2 times 1, negative 2 times negative root 2 minus 2 root 2. Then you will see those two cancel each other out to get negative 2. Okay, I'm going to take a picture, I'll put it on the group, then you can copy. Something I just want to talk about with the last question. You can either do it by changing that 10 to 5 times 2. Okay? The way that I did it here, that you will see on the picture. You remember that sum that we had 2 to the power of 2015 times 5 to the power of 2019. So what I'm noticing here is that these two exponents are the same. Just the a's. Okay? Now do you remember if the exponents are the same, you can multiply the bases. So I took that one out and I made it 10 to the power of a. And I was left with 5 to the power of negative 2 times 2 to the power of 2. And then the whole thing was much simpler going forward. But I will put this one on your group. Okay, go and try it again this afternoon. Please. This whole answer will be on the video as well that I will load to your class group.